In total, these 7 lava flows place 734 million metric tons of metallic lava with an iron ore grade of 50% or higher, a total which is worth $85.8 billion, since this ore has more than the 25% general guideline needed of iron to be able to mine a deposit for a profit. This material is being mined with at least 2 million metric tons of production so far. Okay, so we have established that Elo in its past sometimes produced iron lavas, but could this volcano be a one-off unique entity on Earth? No, as there are other examples, other iron deposits of this exact same phenomena, albeit many and far older volcanic rocks, such as the vast iron ore deposit at Kona in Sweden, which are 1.6 billion years old, along with far smaller but similar deposits in parts of Mexico, Iran, Nevada, Chile, South Africa, and Argentina. These distinctive deposits are quite strange, as typically large economic amounts of magnetite are generally not placed in an extrusive but rather intrusive or sedimentary environments. The associate deposits these iron lavas form are classified as iron oxide apatite or IOA deposits, representing a source of iron quite different to the vast banded iron formations iron is generally extracted from. So how on earth did this iron lava form? The answer is a similar reason to Ol Doinyo Lengai. Why Tanzania's Old Duli volcano has only recently begun erupting natural carbonatite lavas, as these perhaps only 1,000 years ago separated from a fight composition magma to form a secondary magma chamber with a distinct composition. The same occurred at Elo, except it involved a body of andesite magma. There a body of magma was building scientific model at 5 kilometers depth, a depth that happened to mark the bot of the caldera faults created by a prior V6 explosive eruption from this volcano. As MMA pulled in this crustal weak spot, it got so enriched in iron oxide that a threshold was reached. This suddenly caused 2 different composition liquids to separate from one another in a manner similar to adding water to oil. Separated by density, the OC magma rose while the iron-rich magma sunk to the bottom of the magma chamber. However, as the later mag began expanding, it caused increasing pressure to be placed on the heavier iron-rich magma below. This soon caused gas bubbles within the iron magma to expand, which squeezed the magma into existing caldera faults. The Afur-engine magma then roosed the surface, interrupted being placed on each occasion with an average volume of 138 million cubic m of material. This extrusive rock contained 80% by volume of regions rich in iron clinopyroxene, which acted as a matrix that surrounded the approximately 20% economic area rich in magnetite, which had occurred without the presence of the caldera faults at the bottom of this magma chamber. It is highly unlikely that this iron lava would have ever erupted in its rarity worldwide. This does, however, suggest that more such undiscovered deposits may lie hidden underground.